Welcome to EDU 556, Module Number 1, Introduction to Educational Technology and Technology in Schools. In this module, learners will define educational technology. They will summarize different technologies and systems used in schools. They will explain what content and technology standards are. And finally, they will propose an integration plan to introduce new technology into schools supported by evidence. The Association for Educational Communications and Technology has defined educational technology as the study and ethical practice of facilitating learning and improving performance by creating, using, and managing appropriate technological processes and resources. In summation, educational technology means using technology as a tool for the practical purpose of helping students learn. And this is from FranCom, the course text. When educators consider using technology in the classroom, they must consider the following questions. Does using a specific technology offer the learner a relative advantage over other forms of technology, or no technology at all? Do learners have access to the technology, as in equitable access? Does it help learners acquire new knowledge, and does it allow learners to do new things in new ways? Let's develop some academic language essential to computers. Computer Processing Unit, or CPU, most commonly known as a central processor, is the brains of the computer where most calculations take place. In terms of computing power, the CPU is the most important element of a computer system. Hard drive. A hard drive is the hardware component that stores all your digital content in a permanent state. Your documents, pictures, music, videos, programs, application preferences, and operating system represent digital content stored on the hard drive. They can be both external and internal. RAM, or random access memory, is the physical hardware inside a computer that temporarily stores data, serving as the computer's working memory. Additional RAM allows the computer to work with more information at the same time, which usually has a considerable effect on total system performance. Network. A network consists of two or more computers that are linked in order to share resources, exchange files, or allows electronic communications. The computers on a network may be linked through cables, radio waves, satellites, or infrared light beams. Computers connected to a network are broadly categorized as servers or workstations. Shared network folders. Network sharing enables access to information by more than one person through more than one device at the same or at a different time. By connecting a device to a network, other users and devices in the network can share and exchange information through this network. Peripheral. Any of various devices, including sensors, used to enter information and instructions into a computer for storage or processing, and to deliver the processed data to a human operator, or in some cases, a machine, controlled by the computer. Such devices make up the peripheral equipment of modern digital computer systems. Bits, bytes, kilobytes, megabytes, gigabytes, and terabytes are data storage units. For more information, visit the website below. Here is a picture of a central processing unit. This small topography map shows how the CPU or processor controls all computer functions, such as the monitor, keyboard, modem, printer, hard drive, etc. The motherboard houses the CPU and acts as the nervous system for the computer. It supplies ports and circuits to other computer components or peripherals. BIOS contains all the initial commands at computer startup. Hard drive is the permanent storage for computers. It's typically represented as the C drive on most PC computers. RAM is volatile memory, temporary storage for what resources your computer is currently working on or using. Everything is wiped off at shutdown. Network cable, or sometimes called Cat5 or Cat6, connects computers to other computers or internet. A lot of times you see internet drops on walls. A bit is an electronic signal which is either on, represented by a 1, or off, represented by a 0. It is the smallest unit of information the computer uses. 8 bits equals 1 byte. 1024 bytes equals 1 kilobyte. 1024 kilobytes equals 1 megabyte. 1024 megabytes equals a gigabyte. And finally, 1024 gigabytes equals 1 terabyte. There are other units that are much bigger, but for practical use, we typically use megabytes, gigabytes, and terabytes in schools. Academic standards are the benchmarks of quality and excellence in education, such as the rigor of curricula and the difficulty of examinations. The creation of universal academic standards requires agreement on rubrics, criteria, and other systems of coding academic achievement. In the realm of integrated technology, there are technology standards, similar to academic standards that focus on concepts, skills, and dispositions. In curriculum areas, technology standards focus on concepts, skills, and dispositions associated with applied technology use in a learning context. The national level technology standards are presented by ISTE. The state of Maryland has the TL8s, or the Maryland Technology Literacy Standards for students, which outline skills and concepts needed for students to be technologically literate by the 8th grade. There are also the MTTSs, which are the Maryland Teacher Technology Standards, that outline the state's expectations for technology use in classrooms. These standards are very outdated but hold relevance to instruction to this very day. Each county, district, and independent school should also have its own technology standards or curriculum. The International Society for Technology and Education, or ISTE. ISTE inspires educators worldwide to use technology to innovate teaching and learning, accelerate good practice, and solve tough problems in education by providing communities knowledge and the ISTE standards, a framework for rethinking education and empowering learners. In 2016, ISTE revised their educator standards to focus on 7 main themes: that educators must be a learner, a leader, a citizen, a collaborator, a designer, a facilitator, and an analyst. There are also more indicators for each of these standards. For this course, we will draw heavily from the ISTE standards. They are technology standards geared towards K through 12 instruction. Today's students must be prepared to thrive in a constantly evolving technological landscape. The ISTE standards for students are designed to empower student voice and ensure that learning is a student-driven process. We'll use these standards throughout the course to underpin what we do with and for our students. ISTE Standard 1, Empowered Learners. Students leverage technology to take an active role in choosing, achieving, and demonstrating competency in their learning goals, informed by the learning sciences. ISTE Standard 2, Digital Citizen. Students recognize the rights, responsibilities, and opportunities of living, learning, and working in an interconnected digital world, and they act and model in ways that are safe, legal, and ethical. ISTE Standard 3, Knowledge Constructor. Students critically curate a variety of resources using digital tools to construct knowledge, produce creative artifacts, and make meaningful learning experiences for themselves and for others. Number 4, Innovative Designer. Students use a variety of technologies within a design process to identify and solve problems by creating new, useful, and imaginative solutions. Number 5, Computational Thinker. Students develop and employ strategies for understanding and solving problems in ways that leverage the power of technological methods to develop and test solutions. Number 6, creative communicator. Students communicate clearly and express themselves creatively for a variety of purposes using the platforms, tools, styles, formats, and digital media appropriate to their goals. And finally, number 7, global collaborator. Students use digital tools to broaden their perspectives and enrich their learning by collaborating with others and working effectively in teams locally and globally. As a mental exercise, imagine you are walking through classrooms where educators and students are using digital tools for 21st century teaching, learning, and assessment of that learning. List some potential tools you might see being used in the classrooms. Some potential classroom tools includes computers such as desktops, laptops or Chromebooks, tablets like iPads, document cameras, printers and 3D printers, interactive whiteboards, LCD projectors, robotics. Can you brainstorm any other possible technology resources not on this list? For your first assignment, you will make a pitch to purchase and use a technology resource in your school. Here's the prompt. Funding is being made available in your building for the 20 teachers who can articulate the ways in which they feel additional technology resources would benefit their students. You are submitting your proposal to your administrator. Identify the new technology being provided and outline how you intend to use the new technology. Give at least 2 examples. What will you say to make your case? Use the Module 1 readings, the Module 1 presentation, and your own experiences to support your decision. Next, select 2 of your colleagues' posts to provide a meaningful reply to. Replies should be detailed, constructive, informative, and provide advice for the initial poster. After you have replied to the original thread posted by the instructor, and you've replied to 2 of your colleagues' posts, you will take the content that was generated on the online discussion board and you will copy and paste it onto the included Word template. The completed online discussion template is to be submitted to Chalk and Wire in the NDMU SOE General Coursework Portfolio. The Pre-Course Survey, Activity Number 1. Based on the Maryland Teacher Technology Standards, this pre-course self-assessment will assist you in seeing growth throughout the course. Read the directions carefully, place your name at the top, complete the first column only, save it, and submit it to the Joule turn-in spot.